Good morning, students. Let's look at the next part of the work there, that is cam profiles. In that figure that we can see here, the rotation of the cam profile. First place, we've got our follower that's going up and down. In our case here, it's a roller follower. And here's our cam motion or cam that's rotating around the shaft here, or with the shaft. And it is the purpose of a cam is to following a cylindrical shape or disc to get a movement of up and down. Normally that we get it at when we do the cams in a car system to open and close valves in the car injection system and also the cylinder. Now, if you can look at a few definitions, we've got the cam here. That's a rotating disc or cylinder with a shaped edge, a follower, part that rides on the cam, translating the cam's rotation into another motion like up and down. Profile, unique contour of the shape of a cam's working surface. Now, in the motion of a cam, you get three different stages. The rise or the outstroke, if you're working with cars. The follower moves away from the cam center, that's the center here in the middle, and it moves upwards. So that's the rise there. That's, for instance, opening a valve. The dwell, that is when it's at the maximum rotation. It stays there, and that's, for instance, keeping a valve open. The return stroke or the downstroke, and that's when it's going back to the original space or original part there, where it's going to go into the closing of the valve. Now, the types of motions that we can get here, the first one that we get there is the most easiest one, and that's the constant or uniform velocity. CV is the abbreviation we use for that, and it's a straight line up from 0 to the maximum there, and it can also be back to the from the maximum to the 0 there. Then we've got uniform acceleration and retardation, abbreviation is UAR. Excuse me. That is better than uniform velocity, and it reduces the jerk, in other words, sudden movements of that follower. So it's got a nice movement here, basically not the same as a sinodal waveform, but it's a very smooth form, and it gives you a very smooth up and down and open and close motion. The simple harmonic motion provides smooth acceleration and deceleration, ideal for very smoother operation. In this case, you can see it's basically a sine wave that we are drawing here, and we use it then as a follower to get it more nice and smooth open and close motion. Now, when you draw a cam follower, there's a few things that you need to take in consideration. First place is your follower type. Is it a knife edge? Is it a roller? It's a flat roller? It depends on your profile requirements. Roller followers can't have sharp concave curves, so you need very smooth curves to be a roller follower. Applications and needs. Is it high-speed engines? Needs profiles with minimum vibration like simple harmonic motion, while slower machines must use simpler profiles. Aggressiveness. A steeper, more aggressive profiles, upper and closes, but faster, but creates higher forces and jerks. So, what do you need? When you start drawing is you analyze the instructions of the drawing. That's your first one there. You analyze your requirements. Is it a knife follower type? It's a roller or flatbed? What is your lift, your stroke, your minimum cam radius, your angular motions, rise, dwell, or fall? Now, for instance, here's a question. Draw a CV displacement, constant velocity, displacement diagram of cam profile using the following data. Rise 60 millimeters, that's your stroke height. Your movement up for the first 180 degrees is CV. Movement down, CV from 180 to 360. Your rotation anti-clockwise, your shaft diameter, and your minimum diameter. Now, the first thing you do in every question is draw your displacement diagram. We usually draw it in the left-hand top corner or left-hand from your motion or your cam. You construct from 0 degrees to 360 degrees and inclinations. You can use 10 millimeters, you can use 15 millimeters in between, but for each 30 degrees, you must have an interval for that. Your second step is draw the cam profile diagram. In other words, this is your cam profile diagram, where you get your maximum diameter. Now, how do you get your maximum diameter? You need first to draw your minimum diameter from this bottom of your displacement diagram. Excuse me. You get your center line, you draw your shaft here, you draw your minimum diameter, you draw your maximum diameter. Now, this is different than the previous chapter. If the rotation is anti-clockwise, you number clockwise in 30 degrees in the, intervals around. Your fourth step, is to map your profile. Now, for each angle marked on the diagram here, you take it over and plot it to your part there. So you take it horizontally over to the 0 degree line, and with a compass you draw it until it touches the line. The same with the next one. From where it cuts the line there on your diagram, take it over to the vertical line and curve it down to 60 degrees. You do the same with all of them until you reach again 0 or 360 degrees. And then your last step is to complete your profile. Now you take your radius curve or your flexi curve or your French curve. Try not to do it freehand, and you draw your cam profile. And that's your cam profile. If they don't give you a roller or a follower type, use a blade type or a knife type. So that's the standard we use for engineering drawings. So use that one, and then we can complete it. Thank you, guys.